Okay, so our first step here is going to be recording our observations from the lab. We have a starting mass of 73.3 grams, a starting temperature of 23.5 degrees Celsius, a ending temperature of 58 degrees Celsius, and an ending mass of 72.7 grams. The changes we see, first looking at the copper chloride going into the water, that's going to be a physical change. In this process, the copper chloride molecules are dispersed in the water, forming a homogeneous solution. The chemical composition of copper chloride remains the same. It is still composed of copper ions and chloride ions. After dissolving, the change in states from solid to aqueous solution is a characteristic of a physical change. And then next, the crumpling of aluminum foil is a physical change, as nothing is happening besides the crumpling of the appearance of the aluminum. And then when we combine the aluminum foil and the copper chloride solution, that is going to be a chemical change. Combining the aluminum foil with the copper chloride solution results in that chemical change. When aluminum reacts with copper chloride solution, a displacement reaction occurs. So what I mean by this is that the aluminum displaces the copper from the solution, forming aluminum chloride and copper metal. We also see bubbles indicating hydrogen being released as gas. And then three pieces of evidence, three reasons why we know that this was a chemical change is: one, looking at the production of that gas, that's the hydrogen being released. We can see that in the bubbles and the steam. The color of the solution goes from blue to green. That's the copper ions that were originally in the solution. They're being pushed out to form solid copper powder, which is the brown, and you can actually see that stick to the aluminum when you're watching the lab. And then there is an exothermic reaction. So that means that the heat is being released, which is heating up the surrounding water, which is why at the end we can see that there is a higher temperature. And then considering mass law. So what mass law is, the law of conversion of mass states that in a closed system, the mass of system remains constant. It is neither created nor destroyed during a chemical reaction. So what the mass law, it's pretty much saying that the mass is going to stay the same, but in our case, it was not a closed system. The gas was released, as we saw up here. So that shows us that there was a slight change in the mass towards the end, but that's because the gas was released and it wasn't closed, which led to that. And then we're going to classify these as compounds, elements, homogeneous mixes, or heterogeneous mixtures. First, looking at the copper chloride powder, that is going to be a compound. It is just it's two mixtures together, or not two mixtures, two elements together, or ions mixed together in their pure substances. And then next we'll be looking at the copper chloride mixed with the water. That's a homogeneous mixture. Like I stated earlier, they're equally distributed through the composition. And then the aluminum foil is an element. It is a metal. It consists of a single type of atom, and the foil has many qualities of metal. Lastly, we'll be looking at the copper chloride solution and aluminum foil ball combined, that's a heterogeneous mixture. When copper chloride solution is combined with an aluminum foil ball, the result is a heterogeneous mixture. The aluminum foil does not dissolve completely in the solution, leading to the presence of distinct phases, the solid aluminum foil and the liquid copper chloride solution. Now we will be defining these as metals or nonmetals or metalloids. So first, looking at copper, that is a metal. It has many of the properties such as the electrical conductivity, malleability, and ductility. And then chlorine is a nonmetal. Chlorine has that low conductivity and it's pretty brittle. And then we will be looking at aluminum, which is a metal. As we know, it is very conductive, malleable, and ductile as well. Next, we will be finding the protons, neutrons, and electrons in an atom of the isotope aluminum-28. So we know that aluminum has a atomic number of 13. In this case, a mass number of 28. So if with that atomic number, we know there are 13 protons. If it is neutral, there are going to be 13 electrons as well. And then we know that we have to subtract those protons from the mass number in order to find how many neutrons are in this isotope. So you're going to take 28, take away 13 is 15, and that is how many neutrons you have. So 13, 13, 15. Lastly, we're going to be looking at ionic species. So the first one we will be looking at is aluminum. So when it is an ion, what the charge it usually tends to have is what we're going to be looking at. The charge depends on how many electrons it gains or loses, creating a charge either negative or positive. If it loses electrons, it's going to be positive because there'll be more protons. If it gains electrons, it's going to be negative because electrons are negative. So first up, we're going to have 3 plus 3 for a charge of plus 3 for aluminum, because in chemical reactions it tends to lose 3 electrons to achieve that stability. And then next, copper is going to be positive 2 because it tends to lose 2 electrons in order to become stable when it becomes an ion. And then chlorine is going to be negative 1 because in order for it to maintain stable, it needs to gain 1 electron, which is negative.